Okay, so let's talk about scalar multiplication. Scalar means a real number. Scalar multiplication means multiplying a real number and a vector. So let's say V be a two-dimensional vector like so. So let's say V is x1, x2, and let's say C is a scalar. All right. So C into V would give me a new vector such that the elements of the new vector will be C into x1 and C into x2. So essentially when you multiply a vector with a scalar, you multiply all the elements of that vector with that scalar. All right. So let's take a more tangible example. Let's say if I were to multiply, 3 into 3 minus 2. 3 minus 2 is the vector. And the result of this vector operation would be 3 into 3 multiplication with the first element and 3 into minus 2 multiplying the scalar with the second element, and it will be 9 and minus 6. And when you multiply a vector with a scalar, it creates a new vector which has the same direction, only the magnitude of the vector is scaled, and hence the term scalar multiplication. And you can really see why this is the case. So let me draw a vector 3 4 on the xy plane. And let's say I were to draw, let me change the color here. Let's say I were to draw a vector u, which is 3 4. And let's say I draw this vector starting from origin. So I'm going to draw this vector like this, such that the x projection of this vector will be 3 and the y projection of this vector will be 4. And let the angle that vector u subtends with the x-axis be theta. So again, from very standard trigonometry, you can figure out what theta is. So theta is tan inverse 4 by 3. All right. And what will be the magnitude or length of this vector? So let's call the magnitude as LU, and LU will be equal to 3 square plus 4 square. This comes from Pythagoras theorem. So this is 5. Now let's multiply vector u with a scalar, say 5. So, let me call the resultant vector v, and v is the vector which is formed after multiplying 5 and u. So this will be 5 and 3 4, and this will be 15 and 20. All right. And let's say if I were to plot vector v again on this xy plane, the angle that vector v subtends with the x-axis, let's call it alpha, that will be tan inverse 20 by 15, right? And this is nothing but tan inverse 4 by 3, and this is equal to theta. So hence we have proven that u and v are parallel to each other. As far as the magnitude of vector v is concerned, let's calculate that too. So LV is equal to 15 square plus 20 square, and if you take 5 outside of the radical, this will be 5 into this inside the radical, 3 square plus 4 square, and this will be 5 into LU. So in general, if there are two vectors u and v, so let's say there are two vectors u and v, and if u and v are parallel to each other, this really must mean that v is equal to cu, where c is some scalar. And v and u will have the same direction. So v and u will have the same direction if c is more than 0. If c is less than 0, v and u will have different directions.